Let's talk a little bit about normal distributions here in example 10.2. We have two variables that are normally distributed. First, on the left are women's heights. It's given to us in the problem statement that women's heights in the United States are normally distributed. So as soon as you see the word normally distributed, you immediately think that bell-shaped curve. The women's heights have an average of 63.5. So the center, so if we look at the distribution of women's heights, the center of that distribution is 63.5 inches. That's where most women are. And they have a standard deviation of 2.9. So remember, that tells you how spread out the distribution is. The higher the standard deviation, for instance, a standard deviation of 5 is going to look like that. A standard deviation of 1 is going to be less spread out, right? The higher standard deviation, the more spread to the data. The second distribution is of men's heights. It's given to us in the problem statement that men's heights, again, are normally distributed. So you have that same shape, but this time the average is at 68.6. So the center of their curve is a little bit more to the right at 68.6. It's shifted to the right by about 5 inches. And their standard deviation is 2.8 inches. So it's a little bit less spread out. Let's take a point on both of these curves and compare what they mean. So let's take an individual that has a height of 70 inches. If it's a woman that has a height of 70 inches, she's right here. So that's pretty significantly far to the right. In fact, we know that finding areas underneath probability distributions gives us probabilities. So the area right there is the probability that a woman's height is greater than 70 inches, right? Because I colored in the area underneath the distribution to the right of 70. And we can see there that the area is pretty small. But what if a man was 70 inches tall? Because the average height of men are shifted to the right at 68.6 inches, a man measuring a height of 70 inches is really not that far away from the center. It's not that surprising at all. In fact, if we do the exact same thing, and we find the area underneath this distribution to the right side of 70, this is going to give us the probability that a man's height is greater than 70 inches. And you can see the area underneath the men's distribution is a lot larger than the area underneath the women's distribution, because a lot more men are taller than 70 inches than women are taller than 70 inches.